In this lecture video, we'll be solving a numerical based on a state model. The question is as follows. Construct the state model using phase variables if the system is described by differential equation d cube y by dt cube plus 4 d square y by dt square plus 7 dy by dt plus 2 y of t equals 5 u of t. So this is the differential equation which is given in the problem. Let us choose the output is y of t, and let us consider that y of t is having a state variable called as x1 of t. We'll be considering that the state variable of y of t is x1 of t, and the successive derivatives of it gives us remaining state variables. As the order of the equation is 3, the highest order is 3, we'll be having 3 state variables. Now let us consider state variables one by one. We have considered x1 of t to be y of t. So x1 of t is equal to y of t. So in our equation, if we observe, we have y of t, that will be nothing but x1 of t. Similarly, x2 of t is equal to x1 dot of t, which is nothing but dx1 by dt. dx1 by dt is nothing but dy by dt. Hence, we have written as y dot of t, which is nothing but dy of t divided by dt. Similarly, we have considered x3 of t, the third state variable, x3 of t equals dx2 by dt divided dx2 of t divided by dt. So when we differentiate this x2 of t with respect to time, we'll get x3 of t, which is nothing but double differentiation of this y of t. x3 of t is nothing but double differentiation of y of t. The same thing is written here, d square y of t divided by dt square. So we have considered the variables, state variables in this fashion. So clearly, if we observe, dx1 by dt is nothing but x2 of t. How we have got that? If we observe here, this x2 of t is nothing but dx1 by dt or x1 dot of t. Similarly, x2 dot of t equals x3 of t here. x2 dot of t, that is dx2 by dt equals x3 of t. Let us consider dx1 by dt equals x2 of t as equation number 1. Let us consider dx2 of t divided by dt equals x3 of t as equation number 2. Now, by using these two equations, let us substitute or let us obtain x3 dot of t by substituting the state variables which is obtained. So d cube y by dt cube will be equal to y triple dot of t. Means we are differentiating this y of t 3 times with respect to time. It is nothing but differentiation of y of t, differentiation of d square y by dt square, which is nothing but d cube y by dt cube. Similarly, which is nothing but dx3 by dt. The reason why we have written as dx3 divided by dt is because y double dot over here, d square y by dt square is nothing but x3 of t. The same thing is being substituted over here. So in place of this d square y by dt square, we have written as dx3 by dt. So this dx3 by dt can also be represented as x3 dot of t. So this is one more way of representation. Now, if we observe, d cube y by dt cube is nothing but x3 dot of t. d square y by dt square is nothing but x3 of t, which is nothing but x2 dot of t. dy by dt is nothing but x1 dot of t, and y of t is nothing but x1 of t. So using all these equations which we have got, we have substituted all these equations in our main question, whatever they have given. d cube y by dt cube, we have just found out as x3 dot of t, which is nothing but dx3 by dt. So in place of d cube y by dt cube, we have substituted it as x3 dot of t plus 4 times of d square y by dt square. So this d square y by dt square is nothing but x3 of t. So 4 times of, in place of writing this d square y by dt square, we can substitute it as x3 of t. So 4 into x3 of t plus 7 into dy by dt. dy of t divided by dt can also be written as x2 of t. Hence, in place of this dy of t divided by dt, we have substituted it as x2 of t plus 2 times of y of t. This, instead of writing this as y of t, we can represent that y of t as x1 of t, the first state variable which we have considered. Y of t is equal to x1 of t. So in place of this y of t, we have substituted it as x1 of t. So 2 into x1 of t equals 5u of t is written as it is. Now let us write this equation in terms of x3 dot of t. So let us send all these terms towards our right hand side. So when we send all these terms towards the right hand side, it becomes negative. All those signs will become negative. So x3 dot of t will be equal to minus 2 x1 of t minus 7 x2 of t minus 4 x3 of t plus 5 u of t. Let us consider that as equation number 3. Now we have got 3 equations. The first equation is x1 dot of t is equal to x2 of t. The second equation is x2 dot of t is equal to x3 of t. The third equation is with respect to x3 of t, x3 dot of t equals minus 2x1 of t minus 7x2 of t minus 4x3 of t plus 5u of t. Now using these 3 equations, we can get the matrices or state model which we require. We already know this formula. X dot of t is equal to a x of t plus b u of t. Now the 3 equations which we have got here is already known to us. So using those equations, we will get this matrix A and B. A into x of t, that means we have to substitute, we have to extract all the values of x of t. Here we have 3 state variables, x1 of t, x2 of t and x3 of t. So because we have 3 state variables, we'll be getting 3 cross 3 matrix over here with respect to A. So let us write that, how we exactly get that. So we already know the equation. The first equation which we have here is x1 dot of t equals x2 of t. The second equation which we have here is x2 dot of t equals x3 of t. These are the 2 equations which we have. The first equation and the second equation. So using these 3 equations, equation 1, equation 2 and equation 3, let us get the matrix. Now if we observe, to get this A matrix, we already know that x dot of t equals ax of t plus bu of t. So now we already have these 3 equations, equation 1, 2 and 3. So using these 3 equations, we'll get the, or we'll extract the matrix A. Now if we clearly observe, this A matrix is a 3 cross 3 matrix because we have 3 state variables and we have 3 state variables. Let me represent those 3 state variables, x1, x2 and x3. These are the 3 state variables which we have. In our equation number 1, here in our equation number 1, we have state variable called as x2 of t. Only x2 of t is there. Hence, only x2 of t will be 1. The other 2 terms, x1 of t and x3 of t is not there, so it will be written as 0, 0. Hence we have got as 0, 1, 0 over here. Next, similarly, with respect to the second equation, we have only x3 of t. That means x3 of t is the third variable which we have. So only at that particular place we'll be having 1. The other 2 terms will be 0, 0 because in second equation we don't have x1 of t and x2 of t. Hence those 2 terms will be 0, 0. Next, in our third equation, the coefficient of x1 of t is minus 2. So we'll be writing minus 2 over here. The coefficient of x2 is minus 7. So we'll be writing minus 7 over here. And the coefficient of x3 is minus 4. So we'll be writing minus 4 over here. So this is how we get matrix A. Next, similarly, to find out matrix B. Matrix B, to find this matrix B, we'll be using this term called as u of t. Wherever we have u of t, those terms will be considered. If we observe, This u of t is seen only in the third equation. We don't see u of t in first equation or second equation. We see u of t only in third equation. Hence, for the first two values of the B matrix is 0. Only in the third value, third row, we have 5 over here. Hence, we have written 5 over here. This is our matrix B. So after finding out matrix B, A and B, next we need to find out matrix C and D. To find matrix C and D, we'll be using this formula. Y of t equals C into X of t plus D into U of t. We already know that output is Y of t. We have already considered here. We are choosing output as Y of t, and we are considering that as state variable of x1 of t. Hence, the equation is Y of t is equal to x1 of t. Now, according to our equation, Y of t is equal to x1 of t, we using this particular equation, we'll be finding out C and D matrices. We already know that Y of t equals C into X of t plus D into U of t. In this C matrix, we'll be having the values as 1, 0, 0. The reason is we have only one equation over here, and there are 3 state variables. X1 is a one of the state variable, X2 is a second state variable, and X3 is the third state variable. There are 3 state variables over here, and if we observe according to our equation, we have x1 of t. That means we have the first state variable x1 of t. Only there will be having a value called as 1. Apart from this x1 of t, in this y of t, we don't have x2 of t and x3 of t. Hence, the other 2 values will be 0, 0. So this is our C matrix. Similarly, to find the D matrix. To find D matrix, we need to have U of t, which is not there in our output, because output is not completely dependent upon our input y of t, U of t. Hence, D matrix is equal to 0. So this is the required state model using phase variables. I hope that you have understood this video lecture. Thank you.